In this video, we'll be going over buffer solutions and we'll be using ice tables to calculate the Ka value, which will be leading us to the pH of the solution. And I highly recommend that you watch my other video based on the weak acids and base, since I had explained the ice table very in details, and it will help you understand this video then. So let's start from the beginning again. I'll give a small brief. So in this first question, part A, we are to calculate the pH of a solution which contains 0.3 concentration of HNO2, and we are given the Ka value here as this one. So this is not a buffer solution for now, and this is the equation here. And to create the ice table, we basically just write the initial. So the first row is the initial concentration. So we have 0.3 for HNO2 and zeros for the products. And then we do minus x here, and these are going to be x and x. And then this is the equilibrium, the final line, final row. And then we'll get the equation of Ka, which is 5.6 times 10 to the power of negative 4, is equal to x squared, which are the two products, over 0.3 minus x, which is here. And then you do shift solve for x, you solve for x, and then you calculate the pH by using minus log of x. So now let's do part B, which is the buffer solution question. So here in part B, we are to calculate the pH of a solution containing 0.3 concentration of HNO2, and it is given that we have 0.20 concentration of NaNO2. So in here the equation, we are gonna write 0.20 for the initial, and change is still going to be x, and then the final will be 0.2 plus x. So now this is going to make a change when we are solving for Ka. So now let's write the equation again. So here now in the numerator we have x into 0.2 plus x. Since this is the products and the reactant signs, we just have 0.3 minus x. So now you can solve for x using your calculator, and you will get the value of, remember, Ka value is given up here, so you can substitute Ka value with 5.6 times 10 to the power of negative 4, and the value of x is 8.34 times 10 to the power of negative 4. And now you can find the pH value using the negative log of the answer. So, and the base is 10 of the log, and we get the pH to be 3.08. so this is the pH. And they could trick you by asking pOH, so you just do 14 minus this, so that's another thing they could ask you. So now let's move on to the next example, which is a bit more complex. So in this question we are to calculate the pH, so this is very important, pH not pOH, of a buffer solution containing concentrations of NH3 is equal to 0.21 concentration and NH4 is equal to 0.14 m, and they have given you the Kb value of NH3, which is 1.8 times 10 to the power negative 5. So now you can pause the video and try doing this question yourself. For this question I will not make an ice table, so I'll take another shortcut that I have learned. So here they have given you the Kb value of NH3, so this means NH3 is on the left side and NH4 is going to be on the right side. So automatically this is going to be the denominator and this is going to be the numerator. So here we can directly write, and this is going to be same for every question, is going to be x into, this is on the numerator, so it's going to be 0.14 plus x over the left side now, so Kb, I mean NH3 here, so it's going to be 0.21 is equal to 1.8 times 10 to the power of negative 5. So now you can solve for x. So I like to do it on the calculator, as you can do just shift solve for x and you will get the exact value. So here the x value is 2.7 times 10 to the power of negative 5. So now remember, they're asking you the pH, so this is the concentration of the OH negative ion. So now let's just do minus log of this answer. So 2.7 times 2 power negative 5, and this gives you the POH of, so this is the value for the POH, and now pH is gonna be 14 minus 4.57, and this is the answer of 9.43.